bashing my face on it all day. I got the voxel mesher working, and I got it working at high precision, at large scales. We can do 7,000 kilometers, and it still was working. So, so now we're doing a cleanup pass because there's a lot of slop in there. There's a lot of spaghetti. Uh, that might be one of our crashes. So hang on, let's fix one thing real quick. So this was the one we just cleaned up, but I think I think this has to change a little bit. You can go all the way back and then just redo it once I get the thing that I'm looking for. This. All right, now we can redo everything. Okay, and now we can add this back in, except for it's a double F vector, F vector. And then we can do pointer and this. Except it's not a pointer in this case. Okay, maybe it was a pointer. Okay, this was a pointer. This is not a pointer. I think it just looks like this. And then over here, you just a density function. Um, all right, let's do this. Wait, hold just a second. The actor, I think we may actually need the instance level to get set so that it can stay alive. Passing its pointer down. Is it okay to just use the lambda in the constructor and pass down, or should we reference to it to avoid using timing? Okay, yeah, never mind. We'll get rid of it. I'm fine with that. And then auto. Okay, perfect. Okay, so yeah, now we'll start clean up on this. Holds mesh data center, extent edges, stream data, manages real-time mesh lifecycle, edge filtering, logic. Remove that code. Mesh data lock. Update mesh data never called. Okay, so let's go ahead and get rid of this. Get rid of this. I'm just going to close everything except the class we're working on. All but this. And then mesh check. Okay, so mesh data lock. Okay. We're using streams, so we don't need that. Needs rebuild. Never read. Is edge on chunk face. Okay. Delete. Are we using this anymore? I think we fixed the... I think this is defunct now. How about this? Marching tetrahedra uses it, but we were probably going to delete that. In fact, I think we will go ahead and just... F meshing structs, update mesh data. We don't need this. Save. And now we can, let's save this and let's clean out some of these files. Go ahead and close this. We're going to go up to the root and show more options. Generate project files. Marching tetrahedra might be something that we do eventually, but not right now. after everything builds, after our removals. All right, so what was that doing? We're gonna have to go over here. We're gonna actually need this one, it looks like. Generate files. So for the raw, this capture. Okay. Okay. Can changes. Yo, what up, dude? Code cleanup and review. Yeah, bashed face on this for a long time last night, but we got it working. Apparently the constructor does this. Builders are constructed just to trigger add stream. And then immediately destroy when they go extra streams persistent mesh stream. Fmesh stream data. Fmesh stream data. Where you at? Second thing, reset streams is stream data instead. Each builder and calling empty. Yeah, I would rather do that. So that's update mesh chunk stream data in here. Oh. Update mesh chunk stream data. In chunk mesh data. Reset streams. Seems like this should maybe live in the meshing structs as well. Yeah, so we actually, so we have it's performant. Oh, so I'm moving to voxels. Just like there's no reason not to. Originally, I had a really hard time getting it to work with double precision. Uh, but I went through a lot of hoops, and I made all the calculations relative to the chunk's local space instead of the origin of the entire planet or object. So we subdivide down to chunk level, everything exhaustively subdivide the entire tree down to chunk level. Then we check the chunks to see which ones contain surfaces. We build a chunk array out of the chunks that contain surfaces and their nearest neighbors. So we have like one buffer like basically because they can overflow the bounds a little bit sometimes. Um, then at that point, the rest of the time it's only operating on the chunks. It's not doing any more operations on the rest of the tree, just the chunks that we populated in the chunk array. So then it will subdivide those chunks down to minimum depth. And then when you move around, it will subdivide it up until maximum depth. And that ended up being pretty performant. And it also, like, we don't have to process LOD on the entire octree, only on the parts that have data. Um, so it's fast, reasonably fast, because I changed all the calculations of position to be relative to the chunk locations rather than the master location. It means that as long as our chunk sizes are small enough, we can make it really big, like planet size. Like, I was able to go up to 7,000 kilometers radius, which is bigger than the Earth, and it still had precision and collision without like vibrating and such like that. So yeah, now we're just doing like sanity check code review to clean up all this slop. Pick one. Yeah, we're gonna keep reset streams. It also seems like maybe this function should live in the meshing structs instead of in the octree. Update mesh chunk stream is only called from update WAD and initialize mesh chunks. You fold the call site into those and drop the octree method entirely. Let me look at this mesh chunk. Stream data builder. Okay, here's our chunk. Okay, I see. I see. I did not want to have to in place the tree itself in mesh chunk side. Um, so let's take a look at what this does here. Image data. And we Hmm. See it as kind of a toss-up in that case. In which case I would default to leaving it as is. What we could do, however, is have the octree build the raw data, pass that to the chunk handle, actually managing streams, but it's in a parallel for. You know what? Let's leave it. Let us just leave it. Don't think we need this stuff until down here. Unique vertices and triangles. We can also move. There was a struct up here. Yeah, we'll move this into meshing structs though, because that is absolutely something that belongs out here. Okay. Adaptive octree defines a bunch of shirt, comes down here. Everybody seems to be happy with that. This could just go in the header. Adaptive octree header. Not using this. All right, there we go. And then we could just make a signature for this. Yeah, it can be pretty dumb sometimes. I mean, it's just autocomplete. So if the autocomplete function tells it that the most likely number next is 4, that's what it's going to say. Yeah, let's create a signature for a quantized position right here. No, wrong. This doesn't need to be like forced in line. There's no reason to not just have it. We're using it. We might as well. Pre-computed deterministic cache. Is this being used? I don't think this is. Oh, this is just the same thing as our quantized position, just named differently. And then, what about this guy? Am I using this guy anymore? All right, so let's make sure this builds. Yeah, so ah fuck, what is going on here? Those files were deleted though. Why did they come back? Excuse me? Alright, so we gotta do this. I get this cleaned up. Then I had so the goal here. I have my large scale like virtual coordinate universe system going all the way down to planet levels. So now I want to get my planet tech all buttoned up and clean and performant and bug free with like reasonably fast load in time and destruction because I'm going to need to be able to spawn it on the fly. I'm going to need to be able to apply parallax movement to it while it's not performing loud updates and all this stuff. But the first thing, I was, first of all, my other planet implementation has a bunch of noise formulas. That's what we're losing here. I don't have like the planet type noise formulas developed for SDFs yet. I'm gonna have to figure out how to do that. But as far as like extensibility going forward, doing a voxel mesher has so much more stuff we can do with it than just a quadri planet. And the implementation is actually a little bit more graceful as well because it doesn't have a bunch of like special rules and ways to stitch edges together and things like that. It just by virtue of the algorithm produces like contiguous mesh with wad splitting and things like that. So I have this little dual contouring implementation for adaptive voxel meshing that I worked on a while back, but it had an issue. Like I couldn't make it more than not very large, maybe like 100 kilometers before the precision started to break down. But as a part of this effort, the past 2 days, I solved that. And so now it can get just as big as the other planet. And if I can get this just as big as the other planet, then the only real reason to keep the other planet and not just use this is that I've developed a bunch of like noise formulas that will generate different planet types for it. But we can make noise formulas for this too. It's just trial and error work and kind of playing around and tinkering with it, which is the fun part anyway. So, my goal now, my goal now is to get this polished up, clean again, perform it clean. Code makes sense. Not a lot of like extra AI slop laying around in spaghetti. I want it to be able to be spawned and destroyed without causing crashes because we're gonna have to do that if we want to spawn it as a part of our universe system. And then I would pull in the atmosphere shader Mark III that I finished the past few days or the past week or two. I did a re-implementation of my atmosphere shader. It's much nicer. I integrated the ray marching for the ray marching is now integrated to process the atmosphere and the clouds in a single pass. Um, and that's really nice because that allows us to do things like have the atmosphere scattering affect the clouds accurately, have the have it absorb light as it travels through the atmosphere. All right, we have to figure out why this is failing though. So I deleted the marching tetrahedra attempts. Oops. We want try that algorithm in the future. I would branch it off the normal dual contouring, but only that after um, after we have polished it completely. I deleted the files intermediate folder and regenerate VS project file, regenerated the VS project file, but I'm getting errors on file. Oh, they do? I don't think so. They do. Okay. Okay. That's what it was. And then we can come back out, back into our voxel project. We will delete this one more time, delete this one more time. Oh, we have to close this, cancel, close, don't save, continue, show more options, generate Visual Studio project files. Now we should be back in business. Uh, but yeah, so the reason I wanted to go with the voxel approach is primarily because I want to pick an approach, and I don't care if it takes me more time or if it's more work because I'm doing this for fun. that could basically have the most flexibility going forward to do stuff with it. With the quad tree approach, you're really limited on what you can do. Like, you're probably not going to do terraforming. If you do terraforming, you can't dig caves or anything like that. You can only change elevation. Um, you can't, like, you can't do overhanging cliffs. You can't do, like, all your features have to be entirely, like, contiguous with the surface. Like, you can't have something looped over that, like a, I don't know, like a any kind of overhang, you can't do it. An arch, you can't do it. Anything like that, you can't do it. But if we do voxels, we can do all that stuff. Now, is it a little trickier? Yeah, absolutely, it's trickier for sure. Um, but I don't care. That's part of the fun. So might as well. And the primary restrictions that made me pick the quad tree, namely not being able to get actual planet scale, um, are not actually accurate. I can do that. I can get the same level of precision with this as I can with the other planet. So there's no reason not to just go with the voxel thing. And yeah, that's pretty much it. The planet generation becomes a series of noise equations and SDFs. We use this voxel framework, which is like I said, it's actually like conceptually easier than the quad tree because we don't have to do things like map between different quad trees at edge boundaries. Um, Everything's in the same data structure instead of in six separate data structures that we then have to figure out like translations and how to like stitch the edges of those things together and how to stitch the edges of the quad tree nodes together with the larger ones and compute neighbor lookups and all this stuff. I mean, we do have to do neighbor lookups as part of the algorithm, but okay, now we're talking. F adaptive octree, we've got quantized position, and then F adaptive octree quantized position. What? Okay, I'm a little confused by that. We don't need this. All right, what have I done? It also makes it substantially easier to move to a newer version of Unreal. Like I could finally move up to 5.5 or even 5.7. The only thing about 5.7, I don't know if they've changed to be all substrate materials yet, but I don't want to have to relearn. I don't want to have to relearn how to do all that, basically. Aha. Okay, I see. Right, that's what it was. And then we need to see, are we using this anywhere? Yes. Okay. So we do need this. What about this? I don't think we need this. I mean, here's the thing about these version numbers. It's just a huge database of float values that have been trained longer or on different data. Now, there's some wrapping logic built around that that might change, but like the intelligence model itself is just a big old database of floats. All right, where's our failure? Ah, I see. Okay, it's because we're extending something. So back out here, we do need the get type hash. I'm probably in the minority, but I don't like it when it spaces the input parameters like this. Mainly because I like to be able to like collapse stuff and have it be like one line. So these two are not in there. This one should be. This one maybe not. Or maybe they should all be in here. In the header, that is. We just do this. And then back over here, we just need to add them as members. Okay. Hey, there we go. Okay. So you're gonna want to. Just thinking. All right, there's our voxel actor. This is at, I think, 5,000 kilometers in scale. And we can zoom in. Although that was a little hiccup there. I'm not sure why it did that. What is this? We'll have to look at those extra triangles there. Why is it preparing shaders? What the fuck? I mean, good news, we can always roll back. Well, it's stable on the branch we started from, so if we have to, we can just roll back to that. Crash. Interesting. Interesting. An issue where at some point loading shaders ops is adjusting the crashes weren't crashing as stable branch. Changes so far are clean up. Update component signature and the call site. Update component signature and the call site. Um, yes. Formerly, it was working on some content straight. Binaries and intermediate. I deleted binary intermediate, but not binaries. All right, we'll try it. Okay, so delete this, delete this, delete this. What about derived data? Okay. Come on. Slow ass motherfucker. Excuse me. We may see if we can pull a compute shader in here too at some point. I'm not sure what I would use it for. Maybe building the mesh buffers. Let's try one more time. Another thing that's kind of cool is that the mesh in this is not like one chunk, one piece of a chunk, or no, like one entire piece of mesh, like the actual real time mesh for it, is all the same resolution. It's like the real time mesh, like the entire real time mesh, is different resolutions, and we're updating a stream. And the reason that's kind of cool is it means we get collision everywhere no matter what. All right, let's try it again. Are we going to crash? So far so good. Let's speed away. Now, I do wish that there was a better solution to things like that happening, but I don't really know what that would be. It's like the problem is like at the resolution of our chunks, it or of our minimum. I mean, I guess the resolution would be to bump up the minimum subdivision depth, and that would work. But that also increases the load time of our planet until we can get it right. Um, we're not vibrating. Seems to work just fine. Okay, so let's go ahead and make a commit here. Um, clean up mesh structs and some in adaptive archery. Okay. Okie dokie. So that worked. Now we can go back here. Okay. New with cleanup. Now current meshing structs. Is node and chunk. I don't think so. I'm not gonna add this unless stint vac in is node and chunk. Okay, let's try to rebuild without the method, see if it works. If it works, we delete it. Compiled at least. Precision. Very nice. Okay. We do have a little bit of this artifacting, but like we're just showing the normals here. This wouldn't necessarily be what the ground looks like. And even if it did, we would hopefully have like grass camouflaging it a bit and things like that. I do wish I knew. It does feel like maybe, no, right here. forming a connection to a parent node that isn't there anymore, but has not been. Oh, you know, I know what it is. I know what it is. I know what it is. Do 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 do. This is gonna be inside the actor. We added some logic that I think has got to go. Update. Data update right here. Okay, we're just gonna get rid of this. Whoops. We're gonna get rid of all of this. You don't need this. Alright, I bet that fixes it. I added logic to like not do updates if the camera hasn't moved a certain distance. So I think this would actually get like subsequently pruned out probably. Maybe not. Let's try from scratch. Okay, so it did not stop drawing the spike, but it does look like it actually connected to the geometry instead of just having it blasting out into space, which is definitely better. Alright, we're going to want to go ahead and let's try bumping min depth to 8. We got to tear it down. And so like I don't it's not able to like cleanly regenerate itself right now. And that's part of the like life cycle stuff I was talking about. Like basically we're going to have a pool of planets and we'll probably have 5 planet objects that are just always spawned when you're down in star system level. When you get close enough to an actual point where a planet should be, we would regenerate the planet's data and mesh and then move it to the position in question, from like somewhere that you couldn't see it. Like we could put it like it could be anywhere. It could be behind the camera. You know what? It could be wherever. But it's not a hole. I mean, if we push it one layer deeper, we're less like it will pick out more. Like the deeper we push our minimum depth, the more expensive it is to spawn, but the like better its initial geometry is before like going down to the surface. That's pretty slow. pretty fucking slow. Another thing that can make it faster is decreasing the chunk size, but it will also decrease the precision. But maybe we do that anyway, just for now. We'll take it down to 4 and take our size down because, like, honestly, actual planet size is kind of unwieldy to test on, and we could always scale this stuff up later. I still need a way to get it to chunk size 6 without it crashing and burning, because I think to do larger planets than Earth, like substantially larger, then it would be needed. So he changed that loaded pretty quick. Increasing the number of chunks increases the overhead a lot because now you're increasing the number of things that have to invoke update LOD, the number of like separate threads invoking update LOD. So there's definitely a sweet spot somewhere because you don't want to just do it all as one giant update because then you're updating mesh buffers that aren't even affected. This is clearly faster though. Um, I think 4 is probably the sweet spot between precision and update frequency. Because, like, I almost can't even outrun this anymore. I zoom. This would be like the speed of like a fast airplane. And then the best part about making this voxel is that you could terraform this, which is pretty cool. Like you could give the user like a tunnel digging gun, like No Man's Sky style tools, and they could edit the surface. We have a adaptive octree, which is always generates 8 children no matter what. It's not sparse. Every time you split, it will always generate all children. And we have a sparse octree. The adaptive octree picks out the mesh surface. The sparse octree is there to store edits whenever we get around to that, which is not soon, probably. That would be like pretty low on my priorities right now, but that doesn't mean we can't do it. We can do it, which is part of the reason I wanted to do voxels. And I think we can probably offload some of this work to the graphics card as well and make a huge amount of like speed up. But this is pretty reasonable performance. Okay. Um, let's see. Yep. Let's move on to the next one. Let's look at the Autry next. remove octree lock. Would there be any reason why the octree needs access to the parent actor? I was gonna say it could reference like the scaling data of the actor, and we could switch to using that instead of size, which isn't terrible. But you could also just do that computation in the wrapping actor whenever that changes. And there's life cycle stuff you have to do anyway, so that probably makes more sense regardless. So yeah, I can agree with those two. Octree lock and parent actor in the header. Tree lock and parent actor. Do 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 do. I see. They're saying we're passing it in and setting it in the implementation of initialize mesh chunks, but we don't need to do that. We don't need to save this because we already have parent actor used here. So just this is enough. And then get leaves, never called anymore. Find neighbor leaf at edge, never called anymore. Compute position hash. So get leaves and find neighbor leaf at edge. Can only leave the leaves. Split depth, update mesh chunk stream data, quantize position, compute tray, sample nodes around internal, move to private. Yeah. I agree. Um, update mesh chunk stream data moves. Split to depth, update mesh chunk stream data, quantize, and compute tray planner. Split to depth, quantize, compute tray planner, sample nodes around edge. Leaf only using the constructor for neighbor chunk finding. Nope, don't care. Go private. That is why we are here right now. Cleaning up. Getting ready to put out 1.0. Um, Icon's direction 6. I think it's actually called in the actor. Fuck it. We'll just try deleting it. I mean, that's pretty good fidelity at depth 8 from a distance. Pretty good. Oh, it also doesn't have to do the inner chunks unless the SDF. This is it. And then we will have to figure out what happens when you're terraforming and you dig down below the boundary of a chunk, because you would theoretically only be able to modify that. Well, no, I guess you got the neighbor chunks. So you could go pretty fucking deep, actually. Because we put the neighbors in there. Yeah, I think that's probably enough. I mean, you could dig miles deep at Earth scale. Okay, so chunks removed. Static. Static. Okay. I don't know if I have to put the static keyword in this file as well. Um, Initialize mesh chunks. Remove get leaves, find neighbor leaf at edge. Collapse everything. Yeah, I just ran a text message real quick. Okay, so far so good. Change this, change this. Let's go ahead and do some stuff. Uh, nah, I did it. Let's take a look. Clean up these files. Okay, excellent. Yeah, get surface nodes is private. I agree. Uh, yes, I will give you the current node CPP editor file. Right, if we make this commit. Code clean up pass. Clean up tree meshing struts. Your current node CPP and header file. Okay. Octree node. This is the big one. You know it's big when the header is like file. Alright. Shared corner is never referenced. Remove it. Got it. Love it. So let's close everything but this and get the header. F node corner. F node edge. These are going to want to go in the voxel meshing structs as well. But for now, we will leave it. Structure. Full. Is it tripping? I think it was tripping on that one. Shared corners. Okay. Full update. Wasn't there. Find neighbor and get face neighbor leaves. If these were called, it would be that's what I'm talking about. Not getting used. All right. Blam. You're dead to me. Unlock notes, fine. It's not. Find neighbor, get face neighbor. Okay, these are gone. We can delete mirror child, opposite door, face children. Love it. All right, we need to fix the constructors. We can do. Then like this, and then we go back over here. something like this, and then in our actor, in our adaptive octree, actually, that should be the only change for that. All right, merge. Let's trigger some merges. All right, and then we can also yeah, so again, we don't have the clean. Yeah, we fucked something up. Hang on. In adaptive voxel actor header, I want to increase our update time baseline. And then we're going to figure out how to make all this stuff like stable in Blueprint eventually, just not right now. That should double the update speed. But like there's going to be a balance between like how much can it actually do. It's like doubling the minimum amount of time you allow it to take doesn't matter if it's taking more than the minimum amount of time to do the thing. So like there's a functional minimum on these at some small value. Okay, something wrong then. Two. What did we change? What are my changes? Oh, that's it right there. Okay. That's my dyslexia acting up. That would cause a problem. Okay, so I think we're already bumping up against our functional like timer limit here. So, oh, wait. I changed these, huh? Never mind. And then, so if I set this at 0.1, what happens? We're trying different configurations. And like all of this like tunability here is going to be important when we want to integrate this with like the parallax shit because we can't have this doing lot updates while it's also doing parallax. It'll get all fucked up. We're going to have to be able to move it, um, like basically lock it. And what we'll probably do is when it first spawns in, it'll just subdivide to like chunk level and then be done. And then we'll figure out a way to like kind of load down to the min depth, but like not in a way that blocks the main thread. I just do these both at like omega fast, this would be equivalent to having it in like the tick almost. Do that. 0.02 would be 50 FPS, so all right. And this is just fully open bore. Not bad. Let's spawn in from here so that we can see what the load in. I mean, that was pretty quick load in. It gets to 7 very quick, and then 8 takes a second. You're doing 8 times as many operations for every layer down you go. Um, so like at level 1, you're doing, or level 0, you're doing 1. Level 1, you're doing 8. Level 2, you're doing 64. 3, oh, my brain stopped working. Sorry, I can't do math past that, but you get the idea. Normals are looking good. I mean, this is a 1,000 kilometer radius. We have to go up a chunk count or a chunk depth if we want to do like Earth size, which again is slower because you're having to process more chunks at the same time. We could also do something like once you get here, your minimum depth decreases. Like, we would have to figure out our LOD algorithm a little bit to give it like really, really wide bands on like the lowest few LOD levels. It'd be like, oh, if you're we get rid of the okay, so we get rid of the idea of a min depth, and the chunk depth is just the min depth. But we're gonna say like if you're this big, you get chunk depth on the screen, like, and it ramps, 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 and it's gonna ramp up to like the minimum depth by the time you get like say here. It would be at min depth. And at that point, it stops. You cruise down to the planet. I don't know. Like, there's a lot of stuff we can play with here, but framework seems like it's in place. So, double density, F node edges. Okay. are the files after our cleanup pass? Did I miss thing? Ups, optimizations, fixes. Okay, I see, I see, I see. Um, get surface edges. I get what he's saying. So, edges. Okay. Um, get sign change edges. Is congruent. Okay. Okay, that's great. Sign change edges. Okay, this is compute dual contour. Compute dual contour position. Oh, that's great. Yeah, for sure. We already calculated all this once. We definitely don't want to calculate it again when we've already got it. I think I still have it like opened all the way up, right? Yeah. So if I set these to like 0.1, 0.1, we basically like we gotta balance how much this gets to interact with the game thread with like how fast the updates actually matter at all. Okay, here's a clever idea. Hmm. So I removed the logic requiring a cert. distance. But we are still keeping the last position. If we swapped that back to last camera position, we could get the velocity and predict position on the next frame. That with the camera position on here to the update time, then you use that to predictive project. Next update, use that as sample as our mod update position, maybe. Yeah, so then this is in schedule data update. That's in the actor. Data update. So now we're basically projecting our position forward an interval, and we're going to see if that helps reduce pop-in, because it's going to be like, well, we think you're going to be here, so we're loading that on this frame. All right, and then we're going to try that at 0.01. Now that's pretty cool, actually. There's like a little spring back when you stop, which is fine. And if we increase, so like now we're really incentivized to have these adjusted correctly for like how fast it can actually do the data generation. Now that it's running a little bit faster, we want to increase our WAD factor too and kind of figure out a sweet spot. So let's do wireframe. We're at 8 here. Where's our first lot entry? About this far from the surface. So that make it bigger. It makes it bigger. I mean, the adaptive thing makes it cheaper for us to slow down our lot, or less impactful for us to slow down our lot updates. Like we can do that much with a much lower frequency and still end up having pretty good. Because like at point 0.3 with the other paradigm, you would like be vastly outrunning it, but here we're not. Kind of neat. And then when I get to the very bottom, okay, I see. This, however, is much more expensive. Yeah, so that the next idea that I want to investigate is getting rid of um, the min depth idea, having the chunk depth act as our min depth, but coming up with a LOD function that is like we would load in the object and it would be just like a little piece of shit, but that's because it's going to be a chunk depth of 4. There's no fidelity. We need like basically a function that would be like 4 here, 5, 6, 7. It's actually, hang on. start this over. We need like a function that increases basically exponentially the further away, but it needs to encompass the planet from very far away in like lot levels. So like we want the planet to be like when the planet is this big on our screen, oops, it would be here at the min lot level. When it's like double that, it should be from like 4 to 8. I mean, actually, double would be here. But that's not what we, yeah. It needs to be like, you get the idea. We need a different curve possibly. Okay, that works. Pretty cool. I think point 2 is probably a pretty good sweet spot for the update timers. Um, so it is reading that math controlling when we split merge keeps our tree pretty much balanced. At the same time, currently our flood updates happen when we are pretty close to the planet. If we got rid of the idea of min depth, we could figured out the math it would take both of our current type splitting goes down to low levels, but have tail how shallow extend out further. So while you approach and time you say just before the distance are min depth starts splitting. Now you would naturally be at 80%. Min depth. That would long term. That would hopefully long term make much faster to spawn when, and then after spawn the logging just takes over. It'll do resolution it's supposed for the ML. Okay. Yeah, let's try it. Okay, in depth of octree node header, we're gonna replace our depth bounds with no, I don't think that's right. Hang on. I think octree node is unchanged. Chunk depth just becomes our min depth in our depth array. We no longer need to store directly. Yeah, then we can get rid of this. And then over here, it's going to be upset with me. Depth bounds 0. receiver. Depth bounds receiver. Depth bounds receiver. Okay, change that. Okay, so back to this. You change that. Okay, I made Actor and tree signature. Remove min depth from the chain. Actor and tree, remove min depth. Okay. We'll leave it chunk depth for now. We're going to eventually change it to min depth, and there just won't be a chunk depth. The min depth is the chunk depth. In fact, you know what? If I do this, then it might actually just work. I think it did. Okay. Min depth from the chain, so that's F4. The constructor might need to change. Nope, it does not. Okay. Octree then. Okay, so Was I getting the max depth? Hang on. Where is this used? Yeah, we should only need to calculate this once. For the whole tree, yeah, okay. We'll do that. Private. You can just do this in the constructor. I'm trying to not have to. Alright, hang on just a sec. I have broken something and I don't know what it was. Yeah, there it is. I remove them in depth property, and then I don't think I need it anymore. I got one here, but bam, bam, and then it just works. Don't know why we need these extra brackets. In depth. Now we get rid of this. And then go here and get rid of this. open. Root constructor signature, just chunk depth and max depth. Okay, so min depth, max depth. Min depth, max depth. At the octree, no, we have to, yeah, okay. We got to change the constructor here. Min depth, max depth. Chunk depth. Do not need chunk depth anymore. Okay, and then over here, this is no longer happy. Get rid of this. Okay. And then adaptive octree is going to be upset. What? Okay. Will it build? Um, if adaptive, okay. The voxel actor. This gives us our like far away waddles. Like we just have to figure out how to tune that equation. Okay, I'm not surprised that we hit a breakpoint error because we changed a lot of shit. So we'll restart it. I don't want to read this. You do it. Okay, I was wrong. Um, didn't think you needed it, but you did. Ah, split it. Okay. Well, so that it holds on to the pointer for long enough to get to it. You see? Oh man. So like our wad bands, the further away it is, the bigger the band should be. So like the band for like 5 should be really big. The band for 6 should be really big. The band for 7 should be really big. The band for 8 is like we're starting to get close to the planet surface now. And if we do it right, then this will allow us to load our planets in really fast, very far away, and then let them just basically churn away, updating their WAD as we're approaching. Can you work? F adaptive octree node root constructor calling anything that triggers as shared before the notice. Okay. Um, I am a dingus. I'm a fucking dingus. This is not needed because it is the same. That's what it was. God damn it. Progress though, I mean, yeah, having the LOD function control the subdivision completely, 100%, I think is the right way to go. Instead of having like this differentiation between min depth and like we could just in the lotting function say if you're under min depth you need to split if we want that. And we may do that, but it'll be much faster and I would probably go to like 6 and then let lotting take over at that point. This is it. I did 2 embarrassing mistakes right there. Or I don't even know if I'm that embarrassed. It just feels like my dyslexia is getting worse as I get older. And now, not only am I flipping things on horizontal axis, but also vertical axis. But whatever. Okay. Let's do it. Alright, so unlit. Yeah, it's all fucked up at that resolution, obviously. But what we could do. Oops. What we could do. Okay, I found it. Have it uploading now to chunk depth. Um, Now we need to update our allotting function. Should split. Dual contour position to the camera position is less than the extent of the max. If index dot num less than 6. And there's your minimum. Oh, but now our yeah, okay. Yes, yes, this is the way. And now we load it in, and the lotting just takes care of like pulling it down. We're not like trying to do it all at once. Okay. So now if we wanted to say so now we don't have separate paths for splitting to depth. We have one path that splits to depth. Boom, the whole tree. And that's used to get to our chunks. And then we have another method that processes everything after that point. We're not doing like kind of weird extra steps. We just let this take over. Okay. Okay. I have it work. Next up, we need to split. Splits should merge. Um, we will need a function that basically has a tail, like up close, it's fine, but we need to be the lower detail others sooner than we are. So added in min d that can still enforce depth. It's just handled by plotting now. Okay. This is nice. Feels like it's chugging a little bit though. God damn it. Maybe not. So I think we want our data updating faster so that like okay. And I mean from this distance it's a complete mess, but also I mean it needs to stretch out a little bit more. And we can control. Oh, So like point 3 and 10. I think this is the opposite. Okay, that is better. But what if I do 3? Okay, yeah, that's closer. That's more like it. That's a little bit more like it. There we go. Now we're talking. Now the only problem is I'm worried that we're gonna over divide. we're talking. The only problem is now he might be a little too small. So schmear. Okay, let's try over here. Might be a little too small. If I bail out of this and I blast my camera up, turn, it's not actually that bad. I think maybe the multiplier would need to go a little bit higher. If I doubled the size of it, that would have a huge effect on the faraway stuff. But how quick do we load the low level? Pretty quick. Fidelity looks good from the surface. Precision's looking fine. I'm not seeing any vibrating. That might have done it. Okay, hang on. We want to load in from out here, and we want to see how long it takes. Boop. Pretty much instant, and then we fly in. Okay. That's pretty good. That's pretty good. I think that's pretty good, actually. Pretty good. I don't like this. The exponent d mul d mul d exponent. And I mean, we probably wouldn't expose that. I mean, I guess we could. Be interested in pseudo screen space bridge as well. The root extent distance estimates the perceived resolution. Same. Let's try a different version. Inline cross double. We just don't use it, and if we like it, we'll clean it up. Let's try it. 'That's pretty nice, actually. That's pretty nice. Can we boost it a bit? 2.5. Would the distance for splitting the node be from the dual contour position or from the node center? Would the distance or splitting nodes calculated from position or the nodes? Okay. So, um, and how do we increase resolution? Reduce screen space threshold? I think it's going to be a combination. I really like the screen space thing here. It's cool. This is too expensive, what we're doing here, though. Save it. Go. What I'm probably going to end up doing is a combination of the screen space method here and the minimum depth method. So we'll set a minimum depth to 6, which is low, but then use screen space to split further. Let's just die. Just die. 0.1 is too much. Okay. 0.5 is too big. We gotta find a balance. 0.2. Yeah, like by the time we... 5. I would expect this to be subdivided past the point of having these artifacts is the problem I'm running into here. Like we should already be at this level by like here. Maybe like here. It's doing too much though. And the updates are very slow because it's trying to do so much. But if I did something like if depth less than min d, turn true. If depth less than min d, turn false. And then we turn this value up. Turn this up. Like pre-dividing things up front actually speeds up the meshing because it doesn't have to divide all these other nodes that are far away. And it also allows us to operate on less chunks because less chunks are being made dirty. What's our timers on? What's our load in experience? Pretty quick, 0.2 seconds. If we can get most of it off the main thread, that might be good enough. Oh, one thing. I want to use extent times 2 though. But this is wrong. And then two times extent divided by distance. That's going to be more accurate screen space size because we're using the diameter. Maybe we just let the data update slow as fast as possible, but only do the mesh every like 10 seconds. All right, and we can actually, from here, tune this a bit. What if I do 0.1? That's much faster. Much faster. Okay. Okay. Yeah, so like having actually a deep min depth is good because it requires us to do fewer chunk updates because our area that we're, I mean, to a limit, we'll try A and see what that's like. This is getting good. Because like part of the load is actually just having all these meshes on screen. The update should be more lightweight though, because we affect less chunks. Try 6 again. Actually, let's put it back down to 4. We're just going to use the chunk. Hmm. Hmm. This is cool because you can just change them in depth on the fly, and it will automatic. It should automatically, yeah, subdivide to it. All right, but what's the actual overhead of going to 8? Because it does. The only problem is just the pure amount of mesh that we get from going to 8. So maybe 7 is the sweet spot. 7.075. I don't know why we did it like this. Let's just do distance in 1. Although, hang on. That's going to be wrong. This also needs it. It's pretty reasonable. Seems to be pretty rock solid. diameters. And I added min subdivision depth so we can control base density. This is actually kind of important. We actually get there's balance between how much mesh we put C and how many chunks are dirty during flat updates. More initial subdivision should result in less chunks being dirty, vice versa. But that has to be balanced against the pure overhead of having trizones as well. No, it's not the same. Chunk depth subdivision is exhaust on the entire tree. Min depth only splits chunks. That does make sense. Um, like it, although if we put min depth in bounds 3, we to refactor our existing methods. Yeah, so we do that, then we go to the octree node, and now this is depth bounds 3. And depth bounds 3. And in our constructor, depth bounds 3 equals annoying. We're just gonna hard code it for now for the root node. The parent nodes can just propagate it. Can I do this? No. Alright. Figures. Probably would have done that in that manner in the first place if I could do it that way. Okay. So that keeps the change internal to this node. And we can add a little to do. To do this into root. Does this work? Probably not at runtime. I'm just going to change the constructor to taking the depth bounds array. Instead of like min, max depth, blah, 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 it will just take in the full array. Where did this get so much extra geometry? What the fuck is going on here? Something got jinked up in translation. Uh, It's kind of like a mismatch in the actual LOD calculations. This is a lot of extra code for no reason. Now we get rid of this. I'm gonna go get some pizza in a little bit. My last meal on this little trip. And then I'll be taking the train back home tomorrow. I just hard coded it inherited the child constructor for now, but it's weird. I'm getting sub thing split when they shouldn't. When I had just the inline consversion wasn't doing that. That's what it is. Oh my god, I'm a dingus. Okay, so it's not 3, it's 2. Derp. Okay. Yep, that would do it. Stop. I I typed the characters. Just go. Just tear the whole thing down right now. We're just gonna tear the whole thing down, spin it up. That's C++ for you. It'll just let you write to the array however the fuck you want, even if the array can't contain it. Glad it didn't write over my Windows partition. And I believe this is actually the same function I used on my quad tree. The same mod function. So that's kind of funny. All right, let's switch it. The constructor time operation. So yeah, so the issue that would make this not quite as fast as you might think is that a lot more chunks have to update. Those chunks are, whereas if we divide to some depth, It's constructor time again, so it's set to the tree. Okay, there we go. That's 6. This is basically like saying how many mesh chunks is a mesh pieces is a chunk level node going to be in charge of. I did want to try something. I want to see what kind of spawn time we look at with a much higher density. It ain't bad. It ain't fucking bad. It's not too shabby. Then we have this, then we're updating our chunks very. We're probably only updating like maybe 1 or 2 chunks at a time. Which means that theoretically our updates close to the planet should go faster, but then the problem is our FPS drops when we have all this mesh on the screen getting rendered. Although it's better in this mode than in wireframe. Pretty neat. Okay, so, and then if I go out to say this far, stop it, start it, boom. Pretty reasonable, except for the slowdown. But we can get 8 times, we can make it 8 times more efficient with just 1 level decrease in resolution. So, let's try that. Yeah, now there's no problem. So it looks like 7's probably going to be our maximum minimum depth that we can do and not lose FPS and performance. But 7's pretty good. I mean, 7 is enough to block out the shape. Let's do a commit. Code cleanup moved to screen space based LOD. Also, we would be pretty unlikely to have quite this torturous of a surface on the surface of our planet. It would be more likely to be some form of figuring out how to apply a height map to an SDF, and then maybe using like Perlin worms or something to cut out holes for caves and shit. Because we're not gonna want like floating pieces of land, at least not usually. I mean, I think No Man's Sky allows it to happen in some planet types. Um, think this should just be hard coded for now. I don't want to depend it on them in depth. We know 7 works and is fast. Okay. Okay. I'm pretty happy with our bond system now. I see. I think I ended up using the same screen method in the quad tree planet. Let me check, because that had a pretty good function. It's taking a bit more into account, actually. Wonder if there are any useful pieces we could pull in. space threshold. But wait, is it not? But hold on. But we have a comp is pretty much the same without having to traverse any hierarchy and make calls on objects which can be stable. Yeah, that's just better. The same place we camera position. Yeah, we don't need to check this unless we have a view location. The view location thing is the best way to track the fucking camera because it works in the editor and in play. I don't know why they don't give the ability to easily pick up the editor camera um, in a blueprint, but they don't. So probably better to just use view locations. Okay. Um, okay, that's fine. We oops. Nope. 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 in camera FOV. FOV. Rename. Screen space threshold. Get a declaration. Double in camera FOV. Name in screen space threshold. I think that should do it. It's gonna crash. the constructor needs to take this in. Set it back to the chunk depth. Let it merge back outward. About to go get some dinner. I played some Magic tonight. Did a ton of work on this over these few days. Okay. One more thing. Um, okay. One more thing. I'm playing with healing that we still need kind of the exponential type tail to cause the far shallower splits to happen further away. Our split behavior close is pretty spot on. We can do it with the minimum split depth. Curious, we can figure out a way to do it via your odd function. We like it to be depth of 7 when the entire tree is around 10 or so of screen. But we don't want to have It's choking. Quick, stop it. We're gonna run out of memory. Step. Um, Hell, man. I think point one, like, then you're multiplying by 10? Or you're increase, like, yeah, it's like, it's gonna push it past the other nodes. It needs to be, like, ideally pretty consistent. I don't think we can do point 0.5. It's probably got to be like 0.75. I think at point 0.5, it's like they're all trying to divide at exactly the same ranges. Like, we'll see. Let's see. Let's see what happens. You don't have to prepare. God damn it. It's stop, stop. No, no, no. Stop, 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 stop. Stop, please. Please kill it. It has to be less than half, because at half, you're essentially putting your child's split time, like the point at which your child would split, at exactly the same point at which your parent would split. Okay. Um, we might crash here. Please kill the process. Please. So, like, anything more than 0.5 would probably work, I think. Come on, let me kill it. Fuck.